Alright, we parameterized button 0, but we would need 2 buttons. Now my life is a little bit easier. I can just copy all this function, call button 1, and go slightly through the code. I could have the same name here for my structure, but just for consistency, I'm going to call line 1 because I know it's in a different place. Button 0 becomes button 1. I'm actually going to make this a little bit faster and going to 100 megahertz. Same thing for your button 0. Kind of sample that GPIO a little bit faster. And structure, everything is fine. Now my pin source is going to be pin source 1, external line 1, and interrupt 1. This is my structure, my NVIC, and make sure that I call this. Let's compile. Oops, I have a mistake. Let's see what is my problem here. It's my structure. Let's change all that and compile, and should be good to keep going. Alright, now let's write our code. Let's write our interrupt routines and do the original code that we want to do, which is this block diagram that you have over here. Alright, let's go back to our assembly file and get the names of our interrupt routines. For line 0, I'm going to use this name over here. I'm going to my main. I'm going to create my interrupt routine. I'm not receiving anything inside. Alright, so what do we do inside of our interrupt routine? We know that we need to clear the flag, so let's check. Let's make sure that the interrupt flag is set. That's done by looking at a variable. So how do I know now where am I going to look inside of these functions? If we go back to our libraries, drivers and source, let's go over the .h because probably it's a little bit easier. Inside of our external interrupt.h, I'm going to have access to the functions related with external interrupts. And I have here a set of functions that manage the flags. One is the get flag status, another one clears the flag, another one gets the interrupt status, another one clears the pending bit. So what is the difference between these get flag status and get interrupt status? They pretty much do the same thing, but there is a slight difference between both of them. If I right click on this function and open declaration, I'll see that this one checks whether the specified external interrupt line is asserted or not, while the get flag checks whether the external line flag is setted or not. So what is the difference between these two? It's on this word asserted. And when you write bug-free software, you don't need this kind of assert technique because you are assuming that you don't have any problems with your code, but we are mortals and we want to keep those kind of asserts active in the code just in case there is a problem in our code. We are able to generate some exceptions and see what's going on. So I highly recommend to do the version that has the asserted instead of just the flag. If I'm deploying the final code after testing everything, then I will go to the flag because these will generate less assembly instructions. But in early stages of development, I will use this one. So let's use this flag. Let's go back to our main code. And this is the flag that I want to check. And this is going to receive an input which tells you the line to check. Okay, good. So the line that I want to check is external line 0. So external interrupt line 0, and I'm going to check if that flag was reset or not. In case that is true, in case it was generated, then I'm going to do my code here, and don't forget that I need to clear my flag. So clear interrupt flag, and that's done by using the other function, the pending bit, which clears the external line pending bits, receives also the line that I want to clear the bit. So I do this one, and let's clear line 0. And we're going to do exactly the same thing for the other interrupt, and then we'll fill the rest of the code. The other interrupt is called 1. I'm going to look at line 1, and that should be more than enough. Let's compile and see if everything is good. No errors. Alright, let's fill the rest of the code now. Alright, let's go back to our goal here. Inside of our interrupt routine of the external interrupt 0, I'm going to blink the red LED by looking at that GPIOA pin 0, which I'm already doing. So now I just need to blink the red LED. So I'm going to use a flag. I'm going to call flag 0. And every time that this interrupt routine is called, I'm going to do just the inversion of, or the negation of, the last value of that flag. So it's going to alternate between 0 and 1, so the not. I know that the function to write bits is GPIO write bit, and I'm doing the GPIO port D, doing the red, and I'm passing the flag to turn on and off that, and need to do some sort of delay just for that. This is a bad implementation. Let's just do a for loop. Going to have a variable here, an I, and a random value. I'm just going to put 8, and you can tweak this number to blink at a certain rate, whatever rate you want. I'm just going to run these again. This is just for testing. Let me keep just for testing purposes. Bad implementation, because we don't know exactly how much time this is taking, and inside of an interrupt routine you probably don't want that. All we need to do now is to declare the variables. I is a local variable. I can declare it here, int, and flag is something that if I leave these, I want to have access to this variable, so I'm going to declare as a global variable, and the char flag 0, I'm going to initialize to 0. This is the only place that accesses these flags, so I don't need the volatile word here, so everything is fine. And now let's go over the external interrupt 1. This one now, what it's doing is, so we just did the code that is inside of this. Now the other one is just going to detect and use a flag to communicate with your main task. Alright, cool. So let's go to our code here. We already detected. So all I need to do is to create, let's call an interrupt routine flag from this external that I'm going to put at 1. This is going to be now a global variable that is going to be called volatile, because we have 2 points that are going to use this variable. Let's call it char for now, and we can initialize it to 0, 2. And that interrupt is done. Now I go to my main function, and I just need to look at that flag, and if that flag is equal to 1, which can be this, all I need to do is I reset my flag, so I do the same thing. So notice that I'm resetting here the flag inside of the handler, but I also need to reset my software variable. And now I can have also a flag. So let's declare here two variables, because we are repeating pretty much. Initialize them to 0. We are repeating the code that we had over here. I'm going to copy and paste it here. And change, cannot call flag 0, it's called flag. And instead of the red, I'm doing the green. And this is your flag. Alright, let's compile. So I get a problem because I don't declare. I declare LED green. Let me go here. I have another problem here that I didn't notice earlier, so careful, because I call LED red. Alright, let's compile now. And should be good to go. Beautiful. Let's deploy the code. Let's press play, and now I have the button taking care of the red LED and the other wire taking care of the green LED. You probably noticed that the first time that you run the code after compiling, you had the blue button turning on and off the red LED, but then even if you connect a wire on your PA1, you will have the green LED switching like crazy. That's because we have a floating pin on that pin. How can we fix that issue? If you go up to your button 1 configuration, we can actually define a pull up or pull down resistor to our button or to our pin. So if you don't remember what's going on over here, let's go over that structure, open declaration. On my pull up, pull down, I'm going to use a pull down resistor. Going to my main and declare pull down. For my button 0, the blue button, I don't need because the pull up and the pull down are built in on the pin. Actually, it has already a pull down. And now let's compile the code. And once you run, now you don't run into any problems. Your blue button turns on and off on a red LED, and your wire will turn on and off green. Now the only problem that you have is a bouncing problem, but that's a different issue.